स्टार्ट करेंगे। Hello everyone. So welcome to the webinar on IT network security. So I request HOD of Computer Science and Engineering Department, Professor Purnima Raikar ma'am, to welcome the gathering. It's my good morning, one and all. It's my great pleasure to welcome all the. Good morning, everyone. Hello, Vaibhav. It's good to see you. It's my great pleasure to welcome everybody for this webinar on IT network and IT security by my student and my alumni, Vaibhav Patki. And on behalf of Principal Sir, Vice Principal Sir, and KLS Management, I like to welcome you for this session. And I like to welcome all my students, fellow who are eagerly to join this, who are waiting for joining this session and to hear your words. So even Vaibhav had uploaded his motivational video for 15 minutes and also for 1 minute video he has given us feedback of our college, about our college. So I'll not waste much of my time. So we'll proceed with this webinar session. So once again, on behalf of Principal Sir, Vice Principal Sir, and Management and Department of Computer Science, all staff members, I would like to welcome Vaibhav Patki for this webinar session. So we'll proceed with the session. So I'd like to ask Yasmin Madam to proceed with the session, and all the best. Everybody enjoy this session. So good morning, everyone. Hello, Vaibhav. Hope you are doing good there. So with a brief introduction of Vaibhav Patki, we will start with the session. So as I have mentioned earlier, this Vaibhav Patki is our proud alumni, passed out in the year 2009 from Department of Computer Science and Engineering. So Vaibhav is a technical enthusiast having IT experience of 11 years in development, design, especially in cloud security. He has worked in domains like supply chain, logistics, finance, insurance, and with healthcare from last 5 years. He is currently working as technical architect in MERS Life Science, Bengaluru, in the area bringing technology into the drug development. Apart from technology, he loves traveling, music. He is married, has one kid, and he stays in Bangalore with his family there. So with this brief introduction, I request Mr. Vaibhav Patki to begin with the session. Thank you.
All right. Thank you so much for the introduction of having me. So I once again it's proud to first of all have interaction session, but because of the pandemic situation that is going on, unfortunately, we all have to use this virtual session to gather together and do this session. But I would love to be face to face giving these kind of sessions in future, and hope this pandemic will get over soon and we will pass through it. I thank Principal, Head of the Department, ma'am, and Yasmin ma'am, Purnima ma'am, for having me and giving this opportunity to present a small information, whatever I gathered based on my experience about network security. With this, I would like to begin with this topic. Like I said, I am not very, fond or fan, not basically a PPT guy. I believe in keeping an eye contact, talking face to face, doing some whiteboarding, and make sure that the ideas is convinced to person who's listening to it. But let's see how much of this we can utilize virtually, and then how much I can convince you guys, whoever is listening and hearing. I thought I can keep this such session interactive. Not sure how much of this will be possible, but I have tried to make this session not boring by just showing some slides. I have also included some of the exercises and some of the demos live, which I want to showcase. With this, one other thing is there could be some network glitches because of which you may not be able to see the PPTs or hear me. Please let me know, because I may assume that you guys are already able to hear me and then continue. I would be continuing. But please either ping in the chat box or you can just raise your hand or something and give me a hint that you're not able to hear me, and I shall just pause and resume back from wherever I left it. All right. So to say about me, I think Yasmin ma'am has already given an introduction. So I have about 11 years of experience in the field of IT. Started from development design. I moved now into a role of architect, where I work with my team to bring in technology in the area of drug development. Basically, when I say drug development, it is the medicine or the health, medicine development in the area of healthcare, where we kind of use technologies like AI, ML, machine learning, and things like that to produce or deliver the drug in faster way. It could be an IoT, it could be analytics. A lot of things are involved in this. So that is the area where I am working right now. And to begin with this topic, right, IT network security. Let me share my screen. Is my screen visible to everyone? Ma'am?
Yes, Vaibhav, it's visible.
All right, thank you.
You just go for slideshow.
Yeah. So with this topic, right, network security, this is very broad topic. So security is one important topic in every domain, has become one important topic in every domain of software development, right? A lot of people have this concept or thing in mind, where software engineering or computer science is just writing code, developing software, writing algorithms, learning algorithms, learning data structures, right? You develop a software, but what next, right? How can you make sure that your software is not having any loopholes, or how can you make sure that your software is not misutilized, right? So there comes the role of security. And why it is called as IT network security or network security is basically when you do something or when you write an application, it is for you. When you enable it to someone, it is basically enabling the data exchange from your application, which is flowing through the network. It could be any type of network, right? I assume that you guys have already learned computer networks and aware of some basic things like HTTP, HTTPS protocols, TCP, UDP, and those things, right? The wired connections, non-wired connections. So how the data flows through, right? So when you make your application enable or enable to someone to use it, basically you will have to have the network. And if that network is weak, then it is prone for vulnerabilities. So with this thing in mind, any data of a person or an organization, or or it could be an enterprise. How we secure that? So that is the topic, all about network security. So I have classified the topics basically today to cover as the introduction, classification, like how many types of network securities we have, and how can we safeguard our data and things like that. And with that in mind, I have chosen one specific topic today to explain to you all about web application security, because that is the very ongoing thing everywhere in the world, that most of the people right now is used to internet, and they use web applications, they produce web applications, they deploy web applications. So I thought this will be one of the topic which will be of interest to you all. So I assume that, and I've chosen one topic called as web application security, and what are the different types of attacks that is possible for a web application, and how can we prevent them, what is a web application firewall, and I have also planned a bit of demos in between, and also wanted to share the recent live attacks that has already happened, right? So let's move on to the first thing. Like I said, what is network security, right? It is basically a process where you safeguard your data. It could be of an individual data, it could be a data of an organization, enterprise, any data that belongs to you, you want to safeguard it. And how you safeguard it, right? It could be using a certain set of hardware, it could be using any process, it could be using software. You safeguard your data, right? And when I say data, it could be any data, right? It could be a data that is residing in your mobile, it could be data that is residing in your laptop, it could be data that is residing in your pen drive, or anything, right? Starting from a small home to an apartment, to a metropolitan city, to an enterprise, so anywhere, any organization. So protecting such data, safeguarding such data using a hardware mechanism or a software mechanism is basically what we define it as a network security. So how do we classify them, right? We classify them as, like I said, antivirus or anti-malware software, right? I'm sure most of you have already installed antivirus or anti-malware software in your laptop. Why do you think that is essential? So without this software, can you ensure the safety of the data that is residing in your laptop? Right? So most of the people just know that antivirus basically scans and finds the virus. So what is that virus, right? Is it like, so basically antivirus is something, basically it could be a ransomware, it could be a malware. Again, it's a set of instructions, right? A set of instructions, a person, an attacker or a hacker has written that set of instructions to, once that instruction get inside your computer, it gets hold of your root or any executables, and then starts its action, right? So it may replicate from 1 to 100, it may replicate from 1,000 and start reading your confidential information from your laptop, or it could corrupt your operating system, things like that, right? So antivirus is something prevents that, right? Now, application security. For example, if you're hosting an application, like I said, it could be two ways of securing it. One is making sure that when you write a piece of code or an algorithm, that there are no loopholes in your source code. And also, when you host it, you make sure that in your infrastructure, there are no loopholes where an attacker can come in, right? So that is where. Third one is behavior analytics. So basically, there are certain tools in the market which gives you behavior analytics. It is kind of a dashboard where you see a lot of behavior about your network, For example, let's say if a person is using, is kind of sending you thousands of requests in a minute from particular IP address. So that's a behavior, that's a pattern. Unless with these kind of tools, will you be able to know them? No. So there are tools which gives you behavior with which you can know, oh, this kind of pattern is something suspicious and I should be able to take care of them, right? So that is one thing. And third, the fourth thing is firewalls. Firewalls is basically a gatekeeper, right? So you basically put a firewall. It could be a hardware firewall, a software firewall, which is the outermost layer of your network. And then you define a set of rules in the firewall. What should be allowed, what should not be allowed in, what should go out, what cannot go out, right? So these things. And then, the mobile device security. Again, you install a certain set of softwares in your mobile device. Then you kind of create a VPN. VPN is virtual private network. So it's your own private network for your set of people, set of organization, and where the things inside your organization is accessible only for your people. And if something has to go out, it is always made sure that your real IP address is not exposed to the person. It always goes through a VPN server so that it is a peer-to-peer communication. Then web security and then wireless security is basically, a lot of people see that your Wi-Fi passwords, there's strength, WPass1, WPass2, different types of strengths to secure your Wi-Fi. And also you can see this packet spoofing happening these days with wireless networks. So you want anybody who is using the wireless network wants to secure the wireless network, right? Then you kind of build an intrusion prevention systems, right? It could be, you could build your own software, you could build your own hardware to, detect the intrusions. Nowadays, it could, a lot of IoT devices have come basically where they, kind of interface with the routers and they get the data out of the router sensors, and then they kind of show you behavior. They could have written an AI prediction algorithm to predict certain behavior by making the system learn some behaviors, and then you predict if this happens, this is what I visualize, right? So you build your own intrusion prevention systems, or there are readily available solutions by top network players in the market. So these are various ways using which you can, safeguard your data. And like I said, I will be choosing one thing today, that is web application security, and to go over and see how can you secure your web application, right? When I say web application, I'm sure most of you have already learned developing the web applications. It could be using PHP or CGI. I mean, I'm referring to some old terms, but I don't know if it is still the same or has gotten changed. But you develop a website and you host it in a server, and it could be any server like Apache or Tomcat or anything. And then your data, your website is basically enabled over a network. But how do you secure your website, right? For example, if one of you guys are developing a website, let's say to do a hospital management, or it could be a billing system or anything, where you collect a lot of information of a person, right? Is it wise, or is it a good thing that you allow your customers' data to get compromised, right? Nobody would be happy, right? Your customer might not trust you, right? Because your website is very popular and you have around, let's say, thousands of customers, phone numbers, birth date, and anniversary information. A lot of information you have gathered. Since the person likes your website and has trusted you and given you that information, and because of the loopholes in your application, somebody gets hold to that information. right? That is not a good thing, right? It kind of gives you a very negative impression. A negative impression about the product, about your website, and things like that. And it could sometimes lead to legal complications as well. Some of the countries have already taken very strict measures in terms of protecting the personal data. For example, if you go to Europe, they have GDPR laws in place where they kind of protect the personal information of any person, right? It could be biometric information, it could be a phone number, email address, right? It is very sensitive information and nothing has to be compromised. So that's why I said people have very I don't know, it could be lack of information or things like that. Software engineering is not only writing a piece of code, developing an application. It's also your responsibility to develop an application in such a way that there are no loopholes. There are a lot of tools available in the market like Veracode. If you allow your source code to scan through that, it will show you that this particular piece of code is vulnerable for attacks, right? Similarly, you could scan your source code before deploying it or releasing it and make sure that there are no loopholes. That is the software part of it. When you host it, you could also make sure how secure is your infrastructure. Infrastructure is a server. How secure is your server, right? How secure is your network? For example, if you develop a website and you bought a server, like let's say you bought a Dell server in your home, and you got a static IP address from one of the provider like BSNL or Airtel or anyone, and then you hosted your application and everyone is using it. But I am an attacker. I got to know that you are running such an application and I want to attack. If I bring certain attack to your system, is your infrastructure capable of handling that kind of attacks? You just have one server in your home, right? So that is really, really difficult because of the CPU limitation, because of the memory limitations, right? And so many things, right? You have to build your firewall, and then you have to build a lot of network security rules around it to make it secure. So people in earlier days used to do that. They used to add hardware servers, which turned out to be very costly, and the turnaround time was very less, right? You let's say you install your application is running, and customer said, "Hey, there is an attack." You have to go back to the server. Hey, I need extra 7 CPU cycles, extra 32 GB of RAM, and you order it, and those guys ship and it come to you. By the time the attack would have already, trashed your system. So people moved to the hosting providers where they managed the servers on behalf of you, and you pay money to them. And recently, it is now evolved and called as infrastructure as a service, IaaS. There are like platform as a service, infrastructure as a service, software as a service, right? 3 concepts. So Google Cloud, Amazon Web Service, AWS. So they say, I provide you a service, infrastructure, you pay money to me, and you can scale as much as you want, you can shrink as much as you want. So they provide you CPU, memories, and all those things. So it is equally important to secure your applications from the source code point of view and also from the network point of view. And these are the different types of attacks and vulnerabilities that is possible when you host an attack, right? It could be an SQL injection. This is a loophole in your source code, right? For example, you are displaying a list of items in your website. Let's say you have an e-commerce website. You are displaying all the items belonging to a certain location. But there is a loophole where you say select star from something, and that star, I got your URL and I passed some regular expression in that code. So instead of select star, that string is replaced with a regular expression, and boom, I got entire information from your database, right? So how can you prevent this, right? By writing a better code. And cross-site scripting, basically I inject certain scripts into your websites and read your information that you interact, right? Then it could be cross-site request forgery. So when you send a request, I forge your request and I know certain things from it, and I become a man in middle and try to interact with the server. Then remote file inclusion, I include certain files and send it to you, and you download it and your system becomes an infected or things like that. SYN flood, so this is something where your infrastructure capacity comes into the picture. So you will learn what is SYN, ACK and ACK in the next slides. So that is basically a 3-way of SSL handshake that would happen when you interact with any website. So SYN is basically you ping the server. I send SYN packets to the server, 10, 100, 200. I increase it and I create a pool of traffic to the server. Server tries to handle that. Server will not be able to handle that. At the same time, your customers are trying to browse your website. For them, the website becomes terribly slow because I've ensured that consistently the pressure is on with your system, because I want to bring down your system. I want to kill your system. I want to attack your system, but your other customers are not able to use it. Then there is that is a SYN. Continuously, I'm sending a SYN by flooding the SYN packets. And then there is DDoS, distributed denial of service. And then there is man in middle, where I come in as a middleman, and between client and server, I come as a middleman. I take information from server, I send it to you. You think that server is sending to you, but no, the man in middle is sending to you, right? It could be vice versa also. The server thinks that client is sending, but the man in middle is talking to the server. So there are many other things that is possible. Like I said, you can never say that you are secure, because the attackers are running their thinking hats always, and they just need one loophole to crack into your system. So before we move on, I would like to hear from you guys if there are any questions, or if am I moving too fast, or if something is not clear, because I just don't want to proceed fast and then nothing is clear, right? So I'll take a pause here. Feel free if you guys have any questions, or I would then continue with the next part.
Vaibhav.
Yes, ma'am.
Right now nobody have posted any questions as such.
All right.
I think you can continue with the session, and at the end we can start with the question hour. Later on, we can continue with the question session.
All right, but the speed is okay, right, ma'am? Like my net problem with the network bandwidth.
No issues. Everything is fine.
All right, thanks. So I'll just go back then.
Yeah, okay.
So, to prevent these kind of vulnerabilities, there is something called as WAF, that is Web Application Firewall. Like I said, firewall, it could be a software. Like most of you know that firewall, like your Windows also has a firewall, right? Which basically controls incoming and outgoing, what comes in and what you want to allow, what you don't want to allow. You can configure the rules, right? When you host a web application, you can do that as well, right? So a web application firewall is nothing. It's but just a software with set of rules. This is your core infrastructure, where your hardwares and things are running. So web application firewall is something which is the first point of interaction with any traffic. It could be a valid traffic, it could be a malicious traffic, it could be an attacker, it could be a real person who wants to access, genuine person who wants to access your website. So this firewall has a set of rules. which will detect the legit traffic and the malicious traffic and give you the visibility. If you remember in the previous slide, I informed that there are a number of ways, like intrusion detection system. You could also build your behavioral detection system. So this is one such system which gives you visibility, which gives you threat monitoring. You can see if there are any requests coming from a specific IP address. It could be from one particular region. It could be from one particular network. Then you suspect, oh, why is this network? Why there are so many requests coming from one IP address in one part of India, right? Then you are a bit suspicious. Then I think this could be an attacker, right? Then you can see the request headers. They are sending some fake headers, fake information. So those things can be identified in this software, and then it gives you a report. If it is valid, then it sends to this your next application. Otherwise, it will not. Right. So this is, let's see. How this whole WAF. So we spoke about different type of classification of network security, and we chosen web application security, and I informed you what is web application security, what is the need of web application security, and what are the different types of attacks. And now we see that how can you prevent those attacks is by web application firewall. So let's dig deeper and see what is this web application firewall is all about, and how can you achieve it? How can you actually do this web application firewall? Right? Before we dig deeper, I just want to touch on few basic things. Right? I'm sure you guys have already gone through this, like local area network. This for different types of networks, right? It could be LAN, WLAN, campus network, metropolitan network, wide area network, SAN, enterprise network, virtual private network. I assume that you guys have already are aware of these concepts. LAN is basically a local area network. It could be within rooms or within a home where you share the physical wired network. WLAN is a bit larger. Campuses, it could be entire area or combination of 2-3 areas and things like that. Or it could be metropolitan areas where the entire city is covered through a single network. And if you think of wide area network, it could be much larger than that, where 2-3 cities in a different are connected through a topology. And then SAN is basically you have a set of storage devices pooled through a network. And enterprise is basically companies operating in different regions connected through network. And VPN is your own private network, sort of these things. So why I'm just giving you this background is your web application could be running here. Your web application could be running here. Your web application could be running in any of cloud, but you could be operating through any of these network, right? Being a client. So understanding of this network is very important. That is why I just gave you kind of this background. And this is another basic thing, which is OSI model reference, right? So when you make a call, let's say you are a client, you are interacting with a website. So the first layer is basically, you type www.google.com, right? You send a request to the server, and the server responds back to you. So anybody has questions?
Questions as of now.
Okay, I heard some voice. So, all right. So there is application layer, presentation layer, session layer, transport. This layer is very important. So that is why I gave you a bit of background about the networks, right? Anything that you make a request and you receive a response. So this layer 4 is very important. This is where you transport layer protocols like TCP, UDP, all these protocols comes into the picture. So you send request, it goes through your presentation, session, and then basically comes through the network, and then you have your network layer, data link layer, physical layer, and then it gets transported through those wires, and then the server responds back. It comes through the same layer and receives you in the application layer. So this layer 4 is where most of the attacks or things can be controlled, because from your application to the actual network, right? This is the control basically. So for example, if you see most of the web browsers in these days, they don't allow HTTP traffic, right? They say that HTTPS is mandatory. So what is HTTPS, right? So HTTPS is basically a secure HTTP protocol, hypertext transfer protocol, right? So when you say HTTPS, is basically it's TLS, it's an SSL version where your data is encrypted when it flows through the network, and when you have a communication between your server and client. So if you want to just quickly see that, I would take you through this. So if you see this, there is it says that browser can't trust this your connection into this site is not secure. So this is one of the web application, but it says there is a certificate, but I don't trust you. The browser says it don't trust, so it doesn't trust the certificate. So the communication between client and server is always secured using HTTPS protocol, but some of the public certificates the browser trusts, and some of them they don't trust it. If you look at it, right? So how do you think these browsers live, right? There are Chrome, Firefox. What is the revenue model for them? How can they generate money, right? Because everything is free, right? Everybody downloads Chrome, Firefox, right? But there are a lot of certificate providers in the market like Symantec, Tawate, DigiCert, GeoCert. So they kind of provide their public certificate to the browser. If you see, all the browsers have this public certificate already. The browser, when you download a browser, the browser comes with set of public certificates already bundled in the browser. So whenever you browse any website belonging to one of these a certificate issued by one of these certificate authority, the browser automatically trusts it. For example, let's see if you if you go through so if you go through this symbol indicates the connection is secure and the certificate is valid. And if you see here, issued by GTS CA 101, the global sign. Who is the certificate authority? The certificate authority here is global sign, and the global sign is already trusted by the browser. So when I hit google.com, it went through the OSIs, the 7 layers, application, presentation, and then transport, and then it went to the server, and then server responded back, right? The communication was secure between my system and the server of Google. And it was secure because the public certificate was already there in this browser. If you see, the certificate was already there here. If you see the global sign, right? The global sign is already present in my browser. So when I made a request, when I made google.com request, my request was encrypted by the certificate and it was sent to the server, and server identified, oh, this is signed by a valid public certificate. I have a private key, and then the communication was already trusted. So the response was sent back. So I'm sure you guys would have already learned or will learn probably this public-private public key, private key encryption, Alice Bob thing, and all those things in your CN computer network things. But I just want to give you a brief background. What is HTTPS, right? So HTTPS is basically encryption. It ensures that the communication between client and server is encrypted. And there is two things involved in this. That is a private key and public key. The private key is always with the server. It never leaves the server. The public key is basically, that is what I showed in the browser. Any browser that you take in the world, if it is a well-known trusted browser, would have already had most of the famous public certificates of the famous certificate authorities, right? So with this in mind, now I said when I type google.com, how the three-way SSL handshake happens, right? So when I send google.com, the SYN will be sent to the server, right? And the server responds back with SYN to SYN ACK, and server responds back with the ACK. So basically I send SYN ACK, right? And acknowledgement. So client then says, when this SYN ACK happens, the client says client hello, and the basically these hello lines are where the certificate exchange, the cipher suit algorithms, all these exchanges happen, right? And this is the TCP. This initial phase is TCP, and this is TLS. So this is where the transport layer comes into the picture, layer 4, right? That is why I gave you a bit background of that. So when this comes into the picture, the client and server, they do a handshake, and they say, they send client hello, server hello, and then the client says, hey, listen, these are the certificates, these are the algorithms that I can understand, cipher algorithms that I can understand. It could be asymmetric key exchange, symmetric key exchange, Diffie-Hellman. A lot of algorithms have evolved now in terms of this cipher suit program. And then server says, out of this, I understand this algorithm. Let's do our communication using this algorithm. When they both agree on certain algorithm, then the pipe opens, and then whatever communication happens between client and server is always secured, right? So I'll show you how that through an example, but this is usually happens, right? Most of the people just think they type google.com, facebook.com, but what is the scene that is happening behind when you type a website, right? When you actually type a website in the browser, let's say if you type google.com, it basically goes into a DNS server lookup. So the local DNS will be your ISP, internet service provider. It could be BSNL or it could be Airtel. It says, hey, this person is requesting for google.com. Do you have a DNS entry in your DNS server? So there are the DNS lookup server says yes. Then it provides you the response back, and then you go to that server. So basically DNS is basically domain name system, where your google.com is matched with the specific IP address, right? Because without a postal address, how can you reach the destination? You need an address to reach to the destination, right? So it gives you the name, IP address matching. If your local ISP does not have, then it goes to the global DNS server, finds out the address, comes back to ISP, caches it. So that next time you don't have to go to the global DNS, you can always refer the local DNS. And then it sends you the response back. And then when you know the IP address, you can reach the destination. So when you reach the destination, what will happen? The destination is the server, and the request that you sent is a client. My machine is a client, and where you're going is a destination, right? And that is where this whole thing comes into the picture. SYN ACK, client hello, server hello. So let's see with an example how that happens, right? So what I did is basically I captured a packet exchange. So you can capture when you interact with a website, there are tools available to capture the packets to see how I am interacting with the website. So that packet is what I captured, and I'm using a tool to see how it happens. So if you see here, SYN, right? This is the source. Basically, this is my client, this is my browser, this is my laptop, this is the destination, right? I sent SYN to the server, and server then SYN ACK. Then basically SYN ACK is from destination to, if you see the IP address, they are reversed, right? Then ACK. Then the tunnel is established, and this request is executed. So if you see here, it says what is the protocol that I'm using, what is the port, what is the source, and every information is sent to the server. Which is the source, which is the destination, what type of version, IPv4 or IPv6, every information is sent to the server, and then the connection is established. Otherwise the connection will not be established, right? So we will go through that in detail in the next session, but I just wanted to show you how the three-way handshake happens. When you actually type a website in the browser and make a call, this is the scene that is happening in the background. So this is three-way SSL handshake that happens. Once the tunnel is established, the request will seamlessly flow through between when the tunnel is established, meaning the client and server has agreed on certain things. So they agreed on certain things which they say that I know this algorithm and I trust this. So let's communicate using this protocol and this algorithm. It could be Diffie-Hellman, it could be symmetric key, any algorithm they agree on. And sometimes they derive their key. If you take example of Diffie-Hellman, they derive their own pre-secret, and the secret lives within the client and the secret lives with the server also. They never exchange it. But whatever the cipher encryption that client does, and whatever the decryption that server does and encryption that server does, they all happen with their own pre-master which they derive, right? So that is basically Diffie-Hellman, which is very interesting. You guys, if time permits, I would have covered it, but you guys can read that, and that is really very interesting algorithm. So I gave you background, what are the different types of networks, OSI, and how the three-way handshake happens, and what is the layer that we have to protect when there are attacks happening. I informed you what are the different types of attacks that are possible, and we can prevent them using web application firewall, which is a gatekeeper at layer 4, right? So peer-to-peer communication, when you bring layer 4, right? If you go here, when you put a WAF here, right? So your client communicates to the WAF communicates to the server. Your client is not directly communicating, so it's a peer-to-peer communication, right? If the WAF becomes the middleman, in this way, your client is never directly talking to the server. So the this guy becomes intercepts the packet that is coming in and checks for malicious. If there are any, this guy becomes the layer gatekeeper. It checks if there are any malicious requests coming in, and then allow it to flow through. Otherwise, it will not, right? So there are a lot of providers in the market like Akamai, or if you want to build your own, which is really a good project. If somebody wants to work on that, you can choose Apache Mod Security, HA Proxy, Nginx, and build your own PAF, web application firewall. And then you can build a monitoring system around that. So when I say WAF, it is nothing but a server. It's a proxy server, right? It's a proxy server. It gives you logs. So you can read those logs. You can write a program to read the logs, parse the logs, and you can build your AI or prediction algorithm to see what kind of requests am I getting, what browser it is getting from, what region of world I'm getting that from. So if you're getting from China continuously attacks, you can build a monitoring system and you can showcase this. And you can create an alert. If there are 100 requests coming in 10 minutes from one region, send an email to everyone belonging to this website. Then they immediately become alert, and then they start looking, they block that IP address. Right. So this layer 4 is what you can build and make it fat, strong by adding more rules and things like that, and building the monitoring system around that, building an alert mechanism around that, and things like that. So let's see how we can set up the layer 4. Right. When I said I will take you through that. So right? So I have chosen layer 4 as NGINX. Like I said, you can choose, there are like, NGINX. This is a server actually. This is a server, right? And you can choose HA proxy. You can choose HA proxy as another one. You can choose.
Vaibhav,
Yes, ma'am.
your screen is like it has reduced the size. You could just maximize it. Would you present the entire screen? Only part. Earlier it was fine.
Fine now.
No, it's the same thing. It is. You do one thing, no? You stop presenting and once again share the window. You share the entire screen.
Better.
Yeah, it is coming now. Yeah, fine. Now the screen is okay. Okay. Correct. Good. Now we can proceed, Vaibhav.
Okay. So I have chosen NGINX. You could choose Apache, mod proxy as well, right? There are a lot of things. Like I said, layer 4, there are companies, if you don't want to build on your own, you can choose Akamai as WAF, right? They kind of maintain this layer 4 WAF for you, and they add rules to prevent your traffic, right? Incoming and outgoing. If you want to build your own, like I said, one is you need to build your own, then you need infrastructure, right? Like I said, to sustain, you build your software and you host a layer 4 security WAF, but how can you sustain that attack? How can you bear that pressure, right? So you need that infrastructure. So if you go with the providers like Akamai, they provide you the infrastructure also to sustain that capacity of attacks. 1000 Gbps, those are some kind of attacks numbers, capacity that they provide that they can sustain, right? So Akamai, there is a lot of other things like, Incapsula is another one. So these are the companies, they provide you the WAF. They provide you prevention from all these attacks. But if you want to build on your own, you can. So I just tried, try to show you. Probably this could be one of the good exercise if you guys can do it for yourself. So what I am trying to show is I have a sample application running in my laptop, right? So I have a sample application which is running on my laptop. And this is, see, if you see, it is not having HTTPS. It is running on a localhost 8080. Now I want to make this secured, right? So how can I make this secured? This is localhost 8080. I bring one man in front of it. That is called as gatekeeper. So I build a gatekeeper in front of this. Which could act as a WAF, and then I bring this localhost 8080 behind that. So any request coming will first hit this, and then will go through the localhost 8080. So let's see that how I will achieve it, right? So this could be a valid exercise to you guys. I could not complete it unfortunately full, but take a note of this. You guys can build a small application, web application, make it run on your server, and make it secure it by putting a WAF in front of it. Basically, a WAF is any proxy server, HA proxy, NGINX. So your NGINX will receive the first request, and then it will bypass it to your underlying server. So I downloaded NGINX, and this is the configuration for NGINX. It's a proxy server. So what I did is basically I configured the certificate for this. So again, there are a lot of things to cover. You can generate your certificate by using OpenSSL command, that is a self-signed certificate, or if you want to sign by one of the certificate authorities like Global Sign, which I just showed you, your browser trusts that Global Sign, Tabate, Symantec. So those are the few certificate providers in the market where they sign your certificate and give it to you, and you put it in your server. Any request that is coming from the client, the server asks to the CA, is this signed by a valid CA? If yes, then it trusts and allows you. Here, I just signed it by myself using OpenSSL tool, and I have configured a sample server with the rules. So these are the rules here, right? I configure timeout, I configure the protocols that it can support. 1.1 is old now, right? If anybody is coming with that, I don't want to trust. So I have added a rule here. And what I said is, anything that comes in the browser with this, then you just pass it to my underlying Tomcat server. This is the rule that I have configured it, right? And it runs on 443. 443 is always a secure port, right? Few other things that I've configured here is, right, what is a keep alive, timeout, and these are the log formats. Like I said, you can enable the logs for this. You can read this logs. It allows you to print the user agent. User agent is basically the browser. Which browser? It allows you to print the IP address. It allows you to print the request headers, everything. And you can write a piece of code. It could be in Golang, it could be in Java or anything, to read the logs, right? The log is the input to your program. You read the logs and you display the format in a tabular format. Request, IP address, coming from which region, coming from which browser, and then you build a prediction AI ML model around that and show it. This could be a valid project for if anyone wants to do this for your upcoming assignments. This is really one of the wonderful topic for you guys. So I have kept it very thin. When I say layer 4 WAF, so you can add a lot of rules here to make it more fat, right? So you can add a lot of rules here and to make it more strict. So this configuration is what you decide. What are the ciphers that I want to allow? What are the ciphers cache that I want to allow? Everything you can configure here. Based on that, your layer 4 will be strong or weak. Based on how many rules that you add, your WAF acts accordingly. So now I've already configured that. Let's, like I said, based on the rule that I configured, I'll say 443 web host. I already showed you when I hit web host, it basically directs to the underlying server. When I hit this, it sent me to this. It sent me to, there are some things that I missed configuring, probably that is why it is not showing proper, but this is the way ahead. So here, I built this using nginx in my local. This was localhost 8080. This is localhost 443. This was my browser. When I hit, it came to nginx. My nginx checked the rules that I configured. If the rules are okay, it allowed to localhost 8080. Otherwise, it did not. So this way, my localhost 8080 is safe. It is not open to everyone, right? It is like your watchman, or it's like your security guard standing outside. He takes photograph, who requests from where you're coming, everything, all details. If they feel it is valid, they allow you inside. Otherwise, they don't, right? They block you at the gate itself. So that is what I did, just to showcase you guys. Like I said, this could be one of your topic for your project. If anyone is interested, you can work on this, like building a layer 4, hardening it with the rules. You can build your rules, compile it, add it to nginx, and make it more fat and secure. And of course, the infrastructure is something you will not be able to provide because it involves cost. You may choose one of the cloud provider for that. They provide you the infrastructure, and then you do logging. So any incoming request, it logs in. Any request that comes in, it logs in. Because logs is nothing but when you see a watchman, they make an entry in your book, right? Person coming from where, meeting which person, phone number, date, signature, right? It captures all those information. So tomorrow, if somebody wants to check yesterday 4 p.m. who came to my home, who came to my institute, I can always go back and check that book. Similarly, this logs gives you the incoming request entries, and you can build an automated system or a program to read that logs and build a prediction model on top of that. Or it could be basically a behavioral system that you want to build, or intrusion detection system you want to build, or anything that is possible. Right, so this is all I had with respect to security. So we went through the topics. I started with what is security, what are the classifications of it, and then we chose one specific thing called as web application security keeping, because that is the ongoing thing where a lot of attacks are happening, a lot of legal complications are happening because the websites are not safeguarded properly. A lot of personal identities, informations are getting stolen, lost. So, and then we went through OSI reference, the layer 4, how can you secure it? We saw an example of three-way handshake in the Wireshark, and then we saw Nginx configuration for layer 4. So with that, I would say, recent attacks. Some of this, if you want to read, you can read through. There is Charlie Miller and Chris Velasek. These guys, they did a Jeep hack, right? So they hacked a Jeep sitting at some far distance. The Jeep, there was no driver in the Jeep, but they turned on the Jeep, right? So how did they do it, right? Of course, there would be a loophole in the system, that is basically what enables these guys to do that. But these guys were hired by Uber for the kind of work they did. And another one is Mirai bot DDoS attack. This was one of the recent thing where a lot of famous websites like Netflix, AWS, in few regions, they were up. The websites were up, right? But it was not reachable to the customer, because like I said, how the websites are reachable? First, when you hit a website, like if I type Netflix on my browser, it goes to the DNS server. DNS is responsible for giving you the IP address. Then you go to the specific IP address to make a request. But what if the DNS server itself is down? Meaning the post office itself is down. You don't know the address where to go, right? Even if your website is up, you don't get any requests to it. So Mirai bot was one such thing. So it was a malware. It was a piece of program that was written, and it was injected into one of the system. It was a botnet attack. It was a botnet attack which basically infected one of the IoT device, like it could be a CCTV camera. And then those CCTV cameras are not much secured, right? Nowadays they are building security around that, but the device, if one device gets infected, then it was kind of floating to another device, nearest device. Let's say if my CCTV camera got infected, then I scan and get the nearest CCTV, and then I infect that. And so thousands of CCTV cameras in a region got infected, and then they started pinging the DNS server. So it was like 100 requests, 200 requests, 300 requests, 1000 requests, 2000 requests per second, parallelly hitting a DNS server. The DNS server will have certain capacity. The capacity brought down, and the DNS server was crashed. So then, even though the underlying servers, the websites were up, the customers were not able to use them. And then Kenan ransomware attack, basically they noticed that there was a weird behavior that some files were getting modified in a pattern, right? So that was a ransomware where it could have entered your system using someone might have used a malicious pen drive, someone might have already downloaded something and then infected, right? It need not be that let's say if one person has downloaded, need not be that it is only his machine can be infected. If he or she is connected to a Wi-Fi in KLS VDRIT, at the same time, if there are 100 other people connected to that same file can get infected, right? It depends on what kind of malware code or a piece of code that is written in that malware. So it kind of pollute the whole environment. So it depends on the nature of the ransomware attack or the type of attack that the attacker has planned. So these are few things, very interesting attacks that keeps happening across the world. You can never say that you are always secure. Like I said, one single vulnerability is all an attacker needs. This is one of the statement by Chief Security Officer in Windows Snyder at Fastly. So that's like the attackers every day new attacks. They keep learning and attacks, trying to find a loophole in the system, and then they penetrate into your system through that. So there is something called as penetration testing. So you guys have already learned or not, I'm not sure. There is a white box testing, black box testing. So now actually in a people do penetration testing as a black box testing. So I develop a website. I don't give any information about it, and I ask you to break it. So these are some of the testers in the market. This is also another interesting area if you want to go in this area and learn something called as penetration testing. So they will give you a website, and all you have to do is hack it, break it by finding a loophole, right? All I wanted to say is you can never say you're secured. So your security, you build a security system, my job is done. No, you have to keep revisiting your rules, changing your rules and things like that. That is where the intrusion detection system or the program I was talking about, you build it, you feed a lot of learning models to your AI/ML so that it is capable of detecting a new type of threats and give you alerts, warning and monitoring. So this could be one use case for your projects, and with this, I would like to open this forum for question and answers.
Okay. So as of now, no participants have posted any question as such. Okay, so participants, the one who are interested in asking any question can just unmute yourself and you can ask the questions.
Like I said, I am not sure how much I believe in doing this kind of sessions face to face, but I try my best.
But actually, it was a very wonderful session. The things were all very much clear. Like we don't know what is a certificate, we have exactly what a firewall is. Like many of the students, they have just studied in the textbooks, their access of firewall and all that kind of thing. They don't know what basics in the design. Okay, so I think it has given them a brief overview as to what can be done. I think in the final year project, so they can combine ML and the computer network concepts, and they can design their own firewall, and they can predict how a network is secured. So they can experiment in the college network itself, and they can develop a project like this. So participants, anybody who is interested in asking any question can please unmute yourself and ask questions. Is there anybody who is interested in asking any questions? Participants? Okay, Vaibhav, I don't think so. We have any questions from the participants' side. So we have come to the end of the session. So I take privilege to thank Mr. Vaibhav Patki, Technical Architect, Merz Life Science, Bengaluru, for sparing his valuable time and presenting a session on IT network security and he has provided us a very good insight on as to what are the basics of the network securities, what about the OSI reference model he has spoken about. Then he has told us how a network firewall can be designed and a network can be made more secure. So I think our students have gained a knowledge as to what can be done. So that is the networking concepts and the ML, those concepts can be combined together and some useful applications can be developed. So on behalf of KLS VDIT principal, vice principal, management, staff and students and the Department of Computer Science and Engineering, we wholeheartedly thank you for sparing your valuable time and providing a useful talk, a very valuable talk on IT network security for the students, which will help them in their future endeavors to do some good things in network. Okay, and they can utilize these some basic concepts you have told, so they can utilize it for developing a mini project. So might be in the 8th sem they can do a final year project. So in that way, it is going to help you out. Okay, so thank you very much. So in future, I think we are going to trouble you so that we will be asking you for some more sessions or some sort of interactive things as such. So once this COVID goes, so we can have face-to-face interactions with the students, some hands-on sessions we can have.
Definitely.
Okay, thank you, Vaibhav, for sparing such a wonderful time and providing such a you're sharing your knowledge with us. Thank you. So I request Professor Punima Raikar, HOD, CSC department, to just conclude the session.
Vaibhav, it was very good. Even for us, some things of networking were new, like firewall, how like even we can give students mini projects related to that. So I expect more suggestions and guidance. So this time we are also expecting that for our final year students projects. We'll have a co-guide from the alumni, whoever are in which field they are. So whichever projects they are selecting, or we'll have a discussion of final year students with all the alumni. If you can guide them with the real-time applications so that their project can be in a good shape, which will be useful for their future when they will be in a field. So on behalf of department and principal management and everybody, I'm very much grateful to you. Thank you for sparing your valuable time and giving us such a nice, overwhelming session. Okay, thank you. Okay, take care.
Thanks for providing this opportunity and convey my regards to Principal Sir and all the other staff, ma'am.
Yeah, sure. We'll convey your regards. Okay, so in future, we want your assistance in final year project guidance.
Definitely.
So at least one project, if you could guide as a co-guides for the students, so that it will help them in getting placed in better companies, because the final year project matters a lot in their resume as such. So we wish that if you could assist them in the final year project, that will be very much helpful.
Absolutely. Thank you, ma'am.
Oh, thank you. Thank you. So we have reached to the end of the session. So everybody, it is thank you very much. Okay.